Here we are again, guys, jumping back in here for some more work. So this is a question involving calculations from a normal distribution. It says the batteries from a certain manufacturer have a mean lifetime of 870 hours with a standard deviation of 70 hours, assuming the lifetimes are normally distributed. Complete the following statements. Okay, everybody, this is going back to the empirical rule. Okay, let me draw you a picture here. Gotta have a picture. Here we go. So first, all right, so it's going to look something like this. All right, here in the very center, we have the mean. Then we go 1 standard deviation out. We go 2 standard deviations out. We go 3 standard deviations out, right? Same thing on this side. 1 standard deviation, 2 standard deviations, 3 standard deviations. All right. Now, you say, what actually does that mean? Well, let's look here in the middle. Here's the middle where the mean is 870. All right. And we know, right, from the rule given to us, we know that 68% of the data lies in here. 68%. Okay. And this is plus or minus 1 standard deviation. So the standard deviation was what? 70. So if I have 870 plus 70, right, that gives me 940. That's 940 there. And you can see it right here in my calculation, right? What's the lower value? The lower value is, in other words, right here, it is 800. It is 870 minus 1 standard deviation, which is 800, okay? So you just keep going. So that's 68% in the middle, all right? This next is plus or minus 2 standard deviations. So that includes, this is right here, right? This is 95% of the data. And the last one is this one, all right? This is 99.7% of the data lies within plus or minus 3 standard deviations, okay? Plus or minus 3. Let's get a different color here. All right, so this is -1, -2, -3 standard deviations, +1, +2, +3 standard deviations, okay? That is the empirical rule. So now you can easily answer that question. It says approximately 95% of the batteries lie between what and what? Well, that's the plus or minus 2 standard deviations, right? So you can see my calculation right up here. Right? If I just click on this cell right here, you can see I did M1 minus 2 times M2. M1 is the mean minus 2 times the standard deviation, which is M2. Right? That's the lower bound. The upper bound is the mean plus 2 times the standard deviation. Mean is M1 times 2, standard deviation is M2. And we've got it. So you can easily answer that question. Next one says approximately what of the batteries lies between what and what? Lies between 800 and 940. What 800 and 940, everybody, is what? That's 68% of the data right there. 68% of the data is between 800 and 940. Okay? Now, we're not going to stop right there. We're going to go to the next one simply because they are so similar. Okay, so let's go to the next example, next tab, empirical rule. All right. So here we have the scores on a standard test for a certain year are modeled using normal distribution shown below. The mean of the distribution is 76.5. Everybody look over here, M1 again, 76.5. Standard deviation is 5.2. And it wants us to find out the different empirical values, right? What's the number in the middle? V, that's the mean, right? That's the mean. What numbers would U and W be? Well, they're in the first plus or minus 1 standard deviation, right? So they would be 71.3 and 81.7. The next interval out, right, would be 66.1 down here, right? 66.1 to what? 86.9 to be right there. The last one, 99.7% of the data would be from 60.9 to 92.1. And there you've got it, guys. So both of those questions go right together, okay? And obviously this graph is symmetrical. You can see from looking at it, it's the normal distribution. Therefore, it's symmetrical about the mean. All right. And that is it for today, guys. Catch you in class. Take care and have some fun. Bye.